Hello, my name is Harry Kurd. Today I'm going to be discussing the alkali metals, their atomic structure, properties, similarities, differences, and where they are on the periodic table. The group consists of 6 different naturally occurring elements: lithium, sodium, potassium, rubidium, cesium, and francium. These elements are very reactive and are not found unbound but as compounds in nature. They are called alkali metals because of both chemical and physical properties that are shared by the group. Why alkali? They are alkalis. When they react with water, they form an alkali solution. An example is sodium. When added to water, the reaction produces sodium hydroxide solution and hydrogen. It also produces a lot of energy, which can cause an explosion of hydrogen gas. Sodium hydroxide solution is a strong alkali as it reacts with the hydrogen ions in any acid to form salt and water. If you took the sodium hydroxide solution and mixed it with hydrochloric acid, you would get water and, of course, sodium chloride. Sodium chloride is a salt in your dinner plate and the salt in the ocean. Why metals? They are metals as every element has all the properties that are associated with metals. They are shiny, have good conductivity of both heat and electricity, and can be fused or melted. They can be pressed out of shape permanently, called malleable, and drawn into a wire without breaking, called ductile. Of these metals, sodium and potassium are the 6th and 7th most common element found in the Earth's crust and make up about 2.5% each. Lithium, rubidium, and cesium are much less common. Francium is even rarer. It would help to understand the elements' position in the periodic table and how that explains their similarities and trends. The alkali metals form group 1 of the periodic table. Hydrogen is part of group 1, but does not share most of the chemical and physical properties of the alkali metals. The part of the table they are in is called the s block. This is named as the outermost electrons sit in a sphere called the s orbital that can contain at the most 2 electrons. The alkali metals have only 1 electron in this outer shell. In order for that to happen, then any orbitals closer to the nucleus need to be full. As we go down the table, the atomic number increases. This is the number of protons in the nucleus. This can be seen by studying the shell diagrams of these elements. The outer electron does not require much energy to displace, so that the elements easily form ions with a single positive charge. These then can react with anions which have extra electrons. This process is called ionic bonding. This feature determines nearly all of the chemical reactions of the group. It also explains why they conduct electricity well and are soft. The loosely bonded electrons form a cloud, forming a weak bond between the individual atoms. This makes the elements soft and solid with relatively low melting points. It also explains why electrons can easily move from atom to atom, helping electrical conduction. There are many trends that follow the group as it goes down the periodic table. The trends are entirely dependent on the atomic structure. The radius of an atom is controlled by the number of electron shells surrounding the nucleus. For the alkali metals, the radius increases as we go down the table. Thus, lithium is the smallest and francium is the largest. Ionization energy is the amount of energy required to displace the outer electron and become an ion. It is controlled by the distance between the outer electrons and the nucleus. In other words, the radius. As we go down the group, the increase in the charge of the nucleus is balanced by the extra electrons in the inner shells, but their electron in this s orbital is further away from the nucleus and so is less tightly held. This means that less energy is needed to displace it. It also means that elements with a lower ionization energy are more reactive, so potassium would be more reactive than sodium, etc. Melting and boiling points are controlled by similar factors. The group I have chosen to compare to the alkali metals is the halogens. The halogens form group 9 on the right of the periodic table. This group contains 5 naturally occurring elements: fluorine, chlorine, bromine, iodine, and acetine. Unlike the alkali metals with their 1 electron in their outer shell, the halogens contain 7 valence electrons in theirs, with the desire to become 8. A major controller of their chemical behavior is the ease with which they accept an electron to form a negatively charged ion. Thus, they form an ionic bond with atoms that can provide an electron. The physical characteristics of halogens are also quite different from the alkali metals. The group of halogens is the only periodic table group that has elements that are gas, liquid, and solid at room temperature and typical atmospheric pressure. They are not metallic, even the solid iodine and acetine. Bromine is liquid and chlorine and fluorine are gases. As you go down the periodic table, the reactivity of the halogens decreases while the alkali metal reactivity increases, as I have explained. However, the atomic radius goes up, as would be expected. In summary, the periodic table seems to be very useful when combined with an understanding of structure of the elements.